so in the next example that we're going to look at some more theoretical probability problems. In this particular case, we are going to be looking at a standard deck of playing cards. So a standard deck of playing cards consists of 52 cards as shown below. Each of the 4 suits, hearts and diamonds, are red, clubs and spades are black, has 13 cards, numbered ace, which is our 1 through 10, and then 3 face cards, a jack, queen, and king. Even if you are familiar with a deck of cards, sometimes it's easier just to have this image handy, so that way you don't have to think too hard. We can just kind of take a look and see, using our picture, how many of each different card that we're looking for. All right, so we're going to use this picture as we go through. All right, so we're asked to identify a bunch of different theoretical probabilities. So find the probability that the card selected is a 5. So again, we're just going to call this event A because it's example A. If we look in our picture, there are exactly 4 5s. 4 out of 52. If we reduce this into lowest terms, it gives us 1 out of 13. Right, the probability of not a 5. Well, we have a couple of different ways of calculating this. So if we have 4 5s, that means that the other 48 cards are not 5s. Right? That gives us 12 over 13 if we reduce it. Or our probability of B is the probability of the complement of A. So if we take 1 minus our probability of event A happening, because event A was drawing a 5, right? 1 minus 1/13 also gives us 12/13. Right? So we can work through this particular example a couple of different ways. Whatever is easiest for you, that would be what I suggest that you do. Right? The probability of selecting a diamond. We have 13 diamonds out of 52, which reduces to 1/4, which shouldn't be a surprise since it is 1 out of our 4 suits. The probability of drawing a jack, queen, or king, looking up here, right, those last few rows. So in total, our face cards, as we sometimes call them, we have 12 of those. So 12 over 52. If we divide, these are all, both 12 and 52 are divisible by 4. 12 divided by 4 gives us 3. 52 divided by 4 gives us that 13 again. Our probability of drawing a heart and a club, well, that's impossible, right? It's impossible for a card to be both, right? A heart and a club. Right? So draw a card greater than 5 and less than 9. So what that really means here is that we are drawing either a 6, 7, or 8. Right? We have 4 of each of those numbers. Right? So it gives us 12 total. 12 over 52 also reduces to 3 over 13, just like our probability for D did. Right? So calculating theoretical probabilities, you're going to run into a bunch of these different types of questions in the homework. Feel free to use an image of a deck of cards if that's beneficial to you, and or anything else as you're kind of going through. Feel free to use a calculator to assist you in reducing the fractions. Just do be aware that there are definitely going to be some problems where we are asked to write our answer as reduced fractions. So pay attention to that as you're going through. Again, anytime we're doing homework in my math lab, just pay attention that you're giving your answer in the correct form that is being asked for.